Hello, this is Professor Dan Kernler of Elgin Community College, back with another video in my statistics series. This one we continue talking about regression, and we're going to learn about the least squares regression line. All right, let's get to it. For this video, we're going to continue the example when we were analyzing education data. And we had this scatter plot. This was the SAT math average versus the low income density. So the x-axis here was the percent of students that were low income in that school. And the y-axis was the average SAT math score at that school. So to investigate this, let's say we look at 5 specific schools. Just got some example schools listed out here on the graph. And suppose we draw a line. It looks like a reasonable enough line. The question, though, is how do we know if this is the best line? Maybe there's a better line. How do we gauge how good a fit it is? And how can we then find the equation for that line? The way we're going to do it is we're going to focus on the residuals. That is the difference between the observed value, the actual value from the data, and what the line predicted. That's called the residual. Now, analyzing those differences is problematic, much like it was for the standard deviation. Some are negative, some are positive. So instead what we do is we square them. So if I make squares out of those residuals, what we can do is we can then mess with this line and kind of see what line would give us the smallest total square. Now, in fact, what we're trying to do is we're trying to find the least sum of squares. And that's why this is called least squares regression. There are other types of regression. This is the type of regression that we use, and this is without a doubt the most common type of regression. Now, we're not going to be able to get into the theory behind it. I learned that in a graduate statistics course and proved how these models came about. That's much too complex for us. We're just going to learn the basic foundation of it, like where it comes from, which is what we talked about here, and then we'll talk about how to get it in StatCrunch. All right, let's jump into StatCrunch. I have that Illinois school data again. I'll put the link down below if you want to try this yourself. We've done this before when we found the correlation. We're going to go through those same steps. It's stat, regression, and then there are a few regression models here. We just want simple linear. And then we find our predictor for our x. In our case, that was the low income percentage. Then we want our response variable for the y. And that for us was the SAT math average. There's a bunch of other stuff in here. We're not going to touch on that for now. And then we just hit compute. And we get this big mess. So if we pull that printout up here, kind of zoom in a little bit, the top part is all we're going to focus on for now. The bottom part is actually much more sophisticated. We may not even get to that this particular course. We've already talked about the correlation. In this case, it was pretty strong negative 0.7 roughly. So remember, a perfect negative correlation would be -1. So this is fairly strong. What we're going to do now is we're going to move up a few lines. And believe it or not, all of this mess, this is actually the equation for a line. So let's clean it up a little bit. We'll zoom in. Let's focus on those numbers. We want to round them. There's no hard and fast rule, but one thing you'll notice is that the first number is hundreds. The second number is 1 point. So we don't usually round to the same decimal place here. What we do instead is we typically round to the same number of digits. So what I usually do, a good guide, is 3 or 4 digits. In this case here, we kind of look over those. Zooming in and rounding to 4 digits would be 543.6 and then -1.434. So this looks a little bit better. Sometimes I like to clean up the variables. We have this officially percent of student enrollment that is low income, and maybe we can just shorten that, call that percent low income. And now we have the equation for a line. Y equals, it's not really mx plus b here, it's really b plus mx, but it's the equation for a line. Let's talk about those two numbers and what they actually mean. Now, you know this 543.6, that's the y-intercept. Let's look at that on the graph. If we look on the graph, 543.6, that would be this y-intercept. That means when there are no low-income students in a school, the line predicts the SAT math average for that school would be 543.6. Let's talk about the -1.434. That's the slope Now, there are a variety of ways to think of slope. Most people remember something like rise over run. In this case, the rise, the vertical, would be the negative 1.434. It's actually a fall, not a rise. We can put that over 1 for the run. So that's negative 1.434. Now the rise here, the negative 1.434, that's from the SAT math average. And then the run is from the percent low income. So if we think of meaning here, we need some units. The rise will be SAT math, so it's points on the SAT math score. And then the run will be percent low income, each additional percent low income. Now, for me, because our percent low income goes from 0 to 100, it's kind of hard to understand a slope that goes down negative 1.4 over 1. It'd be like really small changes. So sometimes what I like to do is scale it up. So I might look at that fraction and multiply by 10 over 10. That's valid, it's multiplying by 1. If we multiply by 10 over 10, we get negative 14.34 over 10. Now, this might just be a little bit easier to grasp. So now we're gonna have a decrease, it's negative, of 14.34 points on average on the SAT math for every additional 10% of students that are low income in that school. Let's focus on the graph now. Let's just look at that line and let's put a little slope. I don't know if you remember doing this from algebra. We've got plus 10% low income, that's our run, and then a decrease, negative 14.34 on the SAT math. For every additional 10% low income students, we're going to predict a drop of 14.34 points on the SAT math score on average for that school's average. What if we want to focus on one particular school and kind of see how it did compared to what we would have predicted? So we have our model, our SAT math average. It's that y-intercept minus the slope times the percent low income. Let's say we look at Batavia High School. So this has 17.2% low income. So 17.2% of its students are classified as low income. And the average SAT was 552. So pretty good SAT average, but also pretty low percent low income. So we know that there's a strong correlation there. Let's take that 17.2 and put that in for the X in the equation. Put that into the percent low income. And when we compute that, we get a predicted SAT math average of 518.9. When we take the X value from the point and plug that in the model, it gets us the predicted Y. Now, if we compare that to the actual of 552 and look at those on the graph, well, the difference between them, remember, that was the residual. So the residual here, 552 minus 518.9, that's a residual of 33.1. What that means is Batavia High School outperformed the predicted average SAT math by 33.1 points. So given the percent of students that are low income in Batavia, they kind of outperformed what would have been expected based on this really simple model of just using percent of students that are low income. So reminder, that residual is the observed value, the actual Y value, minus what the model predicts. Let's finish with one last StatCrunch command. You can actually get that predicted value directly from that same screen. So if we take our previous output and just go Options, Edit, we can scroll down and kind of toward the bottom, there's a predicted thing. And we can just type in our 17.2 and then hit Compute. And then in addition to all the other model output, I should say, down at the bottom, there will be another row that gives you the predicted Y, which you'll see again is the 518.9 that we got using our hand, just kind of plugging things into the model and computing it. All right, that is it for this video. Thank you so much for watching. If you want to see more of these, you can subscribe, hit the bell to get notified. And always, thank you very much to the Elgin Community College Board of Trustees for approving my sabbatical during the spring 2021 semester. That's what allowed me to take all this time to record and edit and produce and upload all of these videos. So thank you again so much for watching, and I will see you in the next one.